All right. Hi, everyone, and welcome to today's webinar presentation, How to Leverage the Power of Python for Processing Big Data. Thanks for taking the time out of your day to join us. We have a lot of information to go through today, so let's get started. I'm Kendra, and I'm the Marketing and Communications Manager here at ActiveState, and I will be your moderator for today's webinar. There will be time at the end of the presentation for questions, and so if you have any questions, please just use the question function at the bottom of your panel. And if we don't have time to get to your questions, we'll follow up with you by email after the presentation. Now I would like to introduce our speakers. Dr. Mike Müller is the CEO of Python Academy in Leipzig, Germany, specializing in Python teaching and consulting since 2004. He's an engineer who also works in research projects. He uses numerous scientific Python packages on a daily basis and teaches a course on Python for scientists and engineers. He's a member of the Python Software Foundation, chairman of the PyCon DE Conference 2011, and runs Python user groups, and generally is very passionate about developing in the Python community. We also have Diane Mueller, who is a director of enterprise product management here at ActiveState, where she is responsible for managing dynamic language solutions for the enterprise. She has been designing and implementing products and applications embedded into mission-critical financial and accounting systems at Fortune 500 corporations for over 20 years. Now, without further ado, I'm going to pass it over to Diane to go through our agenda.
So good morning, everybody, and thank you for joining us today. I'm really pleased to have Mike Mueller here to walk us through this very interesting topic today. So I'm going to talk today a little bit. I'll introduce who ActiveState is and a little bit about Python Academy. And then we're going to dive straight into the Python and data storage and get an overview of that. And we're going to focus on really getting to the fundamentals, reading and writing data from Excel. You'll learn a lot of the basics here, and then get into the big data, and we'll introduce you to HDF5 and using PyTables. You'll walk out of here with some real good examples of how to do that. Reading and writing the data from PyTables, and we'll talk about how to optimize some of the queries. And then I'll come back on at the end, and I'll talk a little bit about what we're doing to enable you to do this in the cloud with some new stuff from ActiveState. So a little bit about ActiveState. We were founded back in 1997. And we now have over 2 million developers using our products. 97% of the Fortune 1000 rely on ActiveState. ActiveState is the world leader in enabling companies to develop, manage, and distribute applications specifically with dynamic languages. You know, our products and services focus on Perl and Python and Tcl, and other web languages are supported by our Komodo IDE. So if you are looking to run or build applications, whether they're your open source projects or mission critical ones, we have the tools in the dynamic language space to create those end-to-end solutions for you. We are really firmly committed to the open source space, both as supporters of conferences like the one that Mike Mueller chairs in Germany and others, as well as continuing to contribute to the development of the dynamic languages and other projects. Some of our customers include folks like CA, Cisco, Juniper Network, Credit Suisse, and Bank of America, and Lockheed Martin, but we're also very proud of all of the open source projects that we help support and contribute to. And you can read more about that at ActiveState.com or come to ActiveState, the community site, and we'll do that. At the end, you may have heard a little bit about our cloud solution, our enterprise cloud solution for Python Perl applications. It's called Staccato, and I'll talk a little bit about that too. But really what we are about is helping you do the development, manage that development, deploy it, and make sure if you are packaging this up as a product, you can distribute that with our OEM solutions. So today you're going to hear Mike talk about a whole slew of packages in Python that he's going to talk about, and all of those are available in our distributions, both the Community Edition and the Business Edition. These will include things for making your own or rolling your own MATLAB. We kind of call that the PyLab approach, NumPy, SciPy, Matplotlib, as well as any of the Excel toolkits or packages that Mike talks about. They're all in the Community Edition and in our distributions, and the GUI toolkits you need to make those things into real products and push that out there, and as well as database connectors, and if you need to make that secure, the packages for that. So Mike, why don't you introduce a little bit about Python Academy now?
Oh, thank you, Dan. Good morning, everybody. Yeah, Python Academy, that's us here in Germany, and we specialize in Python training, so since 2004, and Python Academy was founded in 2006 actually. And we have a lot of, we do open courses here in Germany. Actually, next week I do one in Colorado, in Golden, but mainly here in Europe. And we also have a lot of custom courses, so we do custom courses for companies. So we customize the course content for different kind of customers, for companies, universities, research institutes. And we have different courses. We have our basic courses like Python for programmers, but also we have specialized courses for scientists and engineers, and many advanced topics, extensions in Python, database programming, and so on. We also offer Python consulting, so we specialize in this type of Python consulting, and we teach and combine teaching and consulting together.
So just to introduce where we're going here today, because I want to make sure people are clear about where we're going. When you're working with big data, we want to be very pragmatic and practical about it and give you some tools to take away today. So we're going to be covering off Excel and Python and how to work with Excel files. We're going to go through HDF5, the hierarchical data format, the most recent one. And then we're going to talk in depth about using PyTables to make sure, which is built on top of the HDF5 library and uses the Python language and NumPy. And we're going to walk through how to use that, make that part of your new, here we have the pink toolkit here, but so that you should be able to walk away today being able to work more effectively with big data. So with that, and no further ado, I'm going to dive right into it with Mike. So back to you, Mike.
Thank you. Yeah, thanks. So let's get started with some overview, Python and data storage, because Python has very, very good support for different kinds of data storage. And first of all, Python itself has some built-in tools and standard library. You just have a quick look on this one to get kind of warmed up. You can store text files and binary files. You can serialize data for very, very simple and easy and fast storage. You also have access to all kinds of databases. You have something called object relational mappers. You can just quick have a look on this one. And then we have a lot of readers and writers, a lot of software for reading many different file formats. And we are going to look at Excel and HDF5 today. So next slide, please. So let's get started. This very simple thing. So pretty much everybody should know this, how to do this in Python. It's very, very easy to open a file. You open a file with an built-in open function, and we use write mode. And then the next one, you just use our file object and write some text in there, close it, and then we can open this file again just without any different with a reading mode, and then we can read the things back in. That's very, very easy. But Python offers a lot of very powerful string processing. You can run your string processing on your text files. And there's also something called the CSV module in the standard library, which helps you to read comma-separate files. So everything that looks like table and is in text format pretty much can be read with it. That's text files, but you can also read binary files. And for this, the standard library offers a struct module. And it's very easy here. As a very simple example, we import the struct module. And then we have this pack command. And the first thing we have to provide is a format. So we want to have a double, a float, an integer, and a short. And then we have to provide our 4 numbers, so 2 floating point numbers and 2 integers. And then we pack it. And then we get a sequence of binary data. And then we can write this, if you like to a file or to something else. And if you read this sequence of binary data, we can unpack it. This is providing the same kind of format and get it back. And you see, you get back the numbers, and you can also calculate the size. So you can read and write any kind of binary data as long as you know how this binary data looks like. Next slide. And also Python offers a lot of serialization, has a few built-in modules which center around pickle, Marshall, pickle, and shelf. This allows you very easily to kind of serialize pretty much any kind of Python object and store it somewhere or send it over sockets or something else. It's very, very simple, just a few commands, and you can serialize Python objects. That's also very powerful. Then if you need to access databases, there's something called the Database API 2.0, which offers a kind of unified application programmer's interface for databases, and this supports pretty much all major databases, Postgres, SQL, MySQL, Oracle, many others. But if you don't want to work with raw SQL statements, you can use what's called object relational wrappers, and the most famous one is SQL Alchemy and also SQL Object, and they allow you to use Python objects and write your programs object-oriented and don't have to bother with SQL, and most of the time they're even faster than when you write SQL yourself. So, next slide please. So there are many other file formats you can use. One of them I use quite frequently is NetCDF, which is simple but also a nice format for numerical arrays. The other one is HDF5. The HDF stands for Hierarchical Data Format, and this one is very good for storing tables and arrays and doing it in a hierarchy. We will have a look at this. You can use Excel, and there are essentially two ways to do this. The first one is a component object model, but this is only possible in Windows because you need the Windows operating system. Or you can read and write Excel data directly using the binary formats that Excel has. And we're going to look at this because we have actually two different ways to do this using pure Python packages to read and write Excel. Next slide. So just to make this clear about the strategy, so pretty much everybody is using Excel. A lot of people that don't program, they live in Excel actually, and you might get a lot of data in Excel, and people ask you to give them Excel data. So Excel is pretty much for exchange with others, but usually not the best way to store large amount of data. For this you can use PyTables with HDF5. This is very well suited for large amounts of data, and you can use a package which we're going to look at to import your Excel data to PyTables. So next slide. Now some examples. First we're going to write some simple Excel 2003. For this we need a package called XLWT. It's a third-party package. You have to install it, and once you install it, it's pretty easy to use. You make an instance of the workbook, which is in this XLWT package, and once you have your workbook, you can add a sheet. You see, you use a Unicode string here to add a new sheet, and now we have a new sheet instance, and now you can write to this sheet, very simple, and which starts indexing with 0, so 0, 0, the first write would be the cell A1, then we would write in B1, and then in D1, and then we write our hello in the next line in A2. And if we have written this, we can just save everything in a file called simpleXLS, and it looks like this. You see back, that's our 100, 200, 300, just written there in our hello. So that's pretty easy. Once we have written it, we can also read it. To do this, we use XLRD. This is a different package from a different author, but works very nice also. So we just open our workbook, simple Excel S, and now we have this book instance, and now we can say book and sheets, gives us a number of sheets in there, so it tells us how many sheets we have saved in here. And also we can access the names of the sheets, so that's what's written on these tabs in the Excel file there. And then we get a reference to our first sheet, so we index it. Index 0 is the first sheet, and then we can have the information, the name of the sheet, the number of rows, the number of columns, and also we can access the value of B1, we can print it out. So, and if you print this out, you'll see in the next slide how it's going to look like. So we see the number of worksheets is 1, of course we had only 1. Then we see back the list of our names, the Unicode string we put in before, and we see that's 2 rows and 4 columns, and the value of B1 is 200. Next. So now we want to write a little bit more sophisticated data in Excel 2003. And for this one, the main difference here, we define styles. So far we just throw everything in just as we get it, but now we want to define styles. We see we have a header style, and we can define the font. We want to make it bold, and we have the size. It's actually 14 points here. And then we have a style for the numbers. So we want to have a numbers with a comma for the 1000 separator and a dot for the decimals. And we have a red style, which is pretty much the same number format, but we want to make the font red. And we have a data style for dates, date style, and this one just has a one a number for the day, 3 letters for the month, and 4 numbers for the year. And now we just create a few dates. So we have 10 dates. We use a built-in datetime module and create 10 datetime instances, starting from January 2002 up to October for 10 of them. And then we have 10 times the text hello, and then we have the numbers -5 to +4. And now we make again an instance, give it a name. In the next slide we see how we can store this thing. So we just do the same thing. We write a header first, addressing our cells by index, write text in there, and then we have a loop. Then we set our n row to 0, and then we loop over all dates, all texts, and all numbers. And then we're going to write our data at the appropriate columns. See, I always increase the row once, and then I write to this column. And if the number is less than 0, then we want to make it red, so we use the number red style. Otherwise, we use a normal number style. So once we write this and save it, you can see in the next slide how it's going to look like. And you see this now. We have our text, which is big font there. We have the date with a month and with 3 letters. And we have the numbers, and you can see all the negative numbers are red. So that's pretty easy. And you can do even more things. You can also write formulas in there. So we can write kind of decently styled Excel files. Okay, let's go to the next. This is Excel. Now we have to read the same thing, which is very simple. So we just have to open it and get an instance to our sheet. As @h is the instance of our sheet. And then we can print out the same information. And we can also go through all the columns and print out the values. And then we have the dates. We can print out the date, and this date can be converted back to a tuple, because dates in Excel are stored as numbers for the days since 1900 or 1904. That different date modes. And this one is just book.date mode. Says you have to know what kind of date mode the file has, otherwise your dates are wrong. So once we do this, if we get this print out in the next slide, you can see the information there. It tells you that we have 11 rows and 3 columns, and then we have the header that we printed out, and then you can see the date. This is the 1st of January 2002, and our number, which is -5. Okay, that's Excel 2003, but next slide we see that we also can do this 2007, because Excel 2007 is very different. It's a different date file format. 2003 is just a binary file, and 2007 is a XML file. And for this, there's a new kit on the block, a new library. It's called OpenPyXL. And this is one library that's useful for writing and reading. So the other one, we had 2 libraries. Now we have only 1. And this one can work with Excel 2007. And it's using XML parsing and writing in the background. So it looks very similar. It's a little bit different, but not so much. So we make an instance of our workbook. Then we get a reference to our first worksheet. We have index with 0 again. Now instead of giving a name, we give it a title. And now we address our cells instead with integers. We address it with this address. It's a normal string, A1, B1, D1, and A2. The same way you see this in Excel, and we just write our values in, and then use the Excel writer instance and give it our workbook, and then we write and save it as a file. And we get the same result as the other one, only it's the Excel 2007 file. And then we can use the same library, OpenPyXL, and now the reader, and we import load workbook. And now we use load workbook just to open our file. And this is very easy now. We can just get the sheets by name. We get a list of all the names. And then we can figure out how many we have just by getting the length of the names. And then we can print out the names themselves. And then we get a reference to the first sheet. And then we can get the data from this sheet. You see title and get highest row and get highest column. So we get the last column. And it looks a little bit different, but not so much. And then we can access our B1 value. And if you do this, we get the same printout as we did for 2003. Next, we can also do it for the more sophisticated ones. That's even a little bit easier. So we have the same data as we had before, 10 dates, 10 texts, and 10 numbers. And now we just open a new workbook, get an instance, set a title, and then we loop through some letters for the columns A, B, and C. And now we set the font. So it's a little bit different here. So we use the style the cell has a property style, which is a font and a size. We set the font size to 14, and we might make it bold, and we can set the font Times New Roman. Next slide, we see that we also can set the other formats. So now we just put in the data, the date, the text, and number as strings. And then we have our loop again through all dates, all text, all numbers. And now we can add the value to our cell and also the text. And then if the number, so same thing with the number, and if the number is less than 0, then we can change the style font and say the color red. So we make an instance of color and make it red. And we save our file and we have it. So it's very similar, a little bit different syntax here and there, but it's very similar to Excel 2003, but we can now write Excel 2007. Okay, next slide please. Once we have written it, we can also read it back, which is very similar, so it's not much difference here. So we use load workbook to get an instance of a book, and then we just get sheet by name, get our first sheet, print out the information about the unnumbered, the title and the number of rows and columns, and then we have a loop through all cells and print the value, all cells in the first row, so it's a header, and then we can access the cell A2 and the cell C2 very easily, just dot value to get the value of the cells. So that's the basics how to use Excel 2007, OpenPyXL to read Excel 2007. So next please. Okay, this is Excel. So now we have basic abilities to read and write Excel files, but eventually we want to put our data in HDF5 because HDF5 is designed for big data. The HDF is called hierarchical data format because you can have hierarchy, very similar to a directory directory in a file system. They have a directory and subdirectories. It's a very similar approach here. And this is designed for storing huge amounts of data. And you can represent pretty complex data in there. And you can have a lot of metadata that describe your data, what they are about. It's very portable, so it's portable over pretty much all kinds of platforms. And can be used for many different programming languages, of course, including Python. And you have a high-level API to program against. And it's very efficient. It's very efficient in terms of runtime and storage. So it's pretty much, as far as I know, it's one of the most efficient ways to store your data. And there's a lot of tools around. So since it's a specified format, a lot of tools around you can use. Once you put your data in HDF5, you can use other tools to manipulate them, not only Python. Next slide, please. So that's HDF5 in general, but we use PyTables. And PyTables is one package written in Python that builds an HDF5. It uses Python and NumPy, so everything you have to know NumPy a little bit to work with it efficiently. And you can use object-oriented programming. And actually, the thing is written in Python. Python is an extension language to Python that allows you to write C extensions for Python. It's a very nice way to do this using Python. And you can create, modify, and search very large data, and it's pretty easy. So I did the same thing with HDF5 as other programming languages, and Python is by far the easiest to do this. That's my experience. And they do use compression to optimize random disk storage, so you can optimize your storage there. And the disk users can be much smaller than with relational databases. Next slide, please. So we're going to look at a few things, a few features. So it's pretty easy to use. You can use NumPy or even NumArray or NumEracle, which are the older versions of NumPy, to store data. And you can use quite a few of data types used there. So you have hierarchy. So you can use this hierarchy. We're going to look like how it looks like in a minute. Then you can use what's called natural naming. That's what you know when you access attributes in Python, you can use the same thing working with HDF5. Just use your object.attribute, for instance. Next slide, please. So you have natural naming. Then you use tables. So you can define tables very similar to a table in a relational database. On those tables, you can add and delete data on the fly. You can index tables, columns. You can use multi-dimensional nested tables. So that's very nice. So if you need a table inside a table, that's pretty easy. You can define it, and one element in this table can be another table. That can be pretty useful. And you have very flexible data containers, tables, arrays, and a lot of things can be compressed, and also arrays are variable lengths, so you can change the size. Next, please. And you can have user-defined metadata, so it is very important. You can describe what your data actually mean. And actually, the size of the data is pretty much unlimited. Even if you have only 32-bit operating system, you have 64-bit addressing, so it means you have 10 to the power of 63 rows you can store there. So this is pretty powerful. We have very powerful data compression in the background, different kind of compressing libs in the background, because usually the disk is a problem and you have enough CPU cycles to compress your data, and so it speeds up reading and writing. And that's why it's a high performance thing. It's designed for performance and uses all these tricks of I/O for modern computers. Next slide, please. Okay, and even if, as I said, even on 32-bit file systems, you can have 64-bit addressing, and it's totally independent of an architecture, so you don't have to worry about little endian, big endianness, whatever. You can just program against the API and it works, and it's very portable. So it supports pretty much all operating systems that are around. Next slide, please. So now you see there's a lot of features. Now see how it's going to look like, and this is one example. So the package is called tables. So we import PyTables package is called tables. We import tables. And the first thing we do, we define a table, and this we do very similar. It's a very similar way as other like object-oriented relational mappers work. You use a class, and this class has to inherit from tables its description. And now we can define how our table is going to look like. Our table has 5 columns. The first one is called name. It's a string type, so we have to define what type it has. So the whole column has one type, and it's a string with the length of 16. And then we have index, which is a 32-bit integer. And then we have 3 floating point numbers. 2 of them are 32-bit, x and y, and that is 64-bit, so it has a higher precision. Next slide. So now we have our table defined here, and first thing we have now to open a file. And for this we use tables open file. We provide a name of a file. Since we have level here, it's kind of measure data like surface levels. So we call it level, and we have to open it in write mode, and we give it a title. So we know this title we all can see later on. Now we have this name, this file name, and the next is we use this file name to create a group. So the next line we use create group, and you see we have kind of a root. So this analogy with a file system, it's very nice here. So we have like a root directory, and inside this root directory we make a new group. Think of we make a new directory, and we can give this directory also some information and name. It's called measured level. Now we have this group, and finally inside this group, the last line, we put a table. For this we call the function create table, and we give it the group and say, okay, we want to have a table called raw data, which has this class level. This is the one we defined before. So now we have our level table with these 5 columns inside, and we give it a command again. Now we have our table, and we go to the next slide to see how we can write in this table. First we see how it looks like. Of course, you see everything is here on the interactive prompt, and if you just print H5 file, then you get some information. You see all the information we just put in, you can get back. It gives you the file name when it's created. It gives you the object tree. So you see the tree, you have a root tree. then you have this group level, and then you have the table raw data, which has 0 rows right now with this command. So you can see pretty much what's inside the file. Next slide. And if you want even more, if you don't use print, you just use what's called a representation. You just type the name. You get the very similar information, but in addition, you get the description of the table. It accurates you back the index name XYZ, so you can see how the table is going to look like. So you have even more information about it. Next slide. So now we have this one. Now we want to put a few data in. For this, we use the random module from the standard library just to create some random numbers. And first thing, we use tab.row to get a reference to our row. So we use just the short name level, don't we have to type tab.row all the time. Next slide. And now we have our row, and now we write in our row. This is very easy. We just have a loop. 10 times we write to level, which is our tab row, the name with a string, index with an integer, and XYZ with some floating point numbers. And then very important, we have to say level append to actually append the data. And next slide, we see now we flush this one. So because it's usually buffered, and we flush this, and then when you close the files, it will be flushed also. But if you want to work on, you can flush it. And then next slide, we see how it's going to look like inside. Can we have the next? Yeah. So there are quite a few tools there, and one of them is called H5LS, LS for listing. So this one can help you to look inside the file on the command line. So now we closed our file in the Python interpreter, and we're back on the command line, and we use H5LS with the option -RB, and just spits out what's inside the file. This is this kind of representation. Next slide, please. But there are also quite a few graphical tools, and that's one of them. That's VTables. Actually, it's written in Python in Qt, and you can see here on the left-hand side you have this typical tree structure, and that's a hierarchy. So our hierarchy is very simple, but you can see you have this group that looks like a very simple little folder, and then you have a table. And on the right-hand side you see the table with the data inside. So you have several of those tools, and some of them even can do visualization and graphics and things like this. Next slide, please. Okay, now we have written a very simple table, and next we want to read it back. So the same very similar procedure. We just open our file again, but this time in read mode. And then we can use what's called natural naming. You see, we say h5 file, this is our file, dot root, dot name of the group, which is called level, dot name of the table, which is called raw data. So as long as you choose names for your groups and your tables that confirm this Python naming rules, so you can use them as Python names, you can use natural naming, which can be very nice at places. So what we do now, we get a reference to our table. On the next slide, we see how we can access it now. See, now we just can go over it with iteros, so we iterate over it, and we can access every row at a time. So that's very easy. So you can access your data going over them if you like to. Next slide, please. You can also do queries, and for these queries you just pure Python, so you don't do anything special. There's no special query language, you just pure Python. And this is a list comprehension. You see, found is our result, and then we use a list comprehension, so we have open square brackets here, and we say x, we call x, we don't know what it is yet. This will be our running index, and then we use name. We index with the name, and then we go through all the iteros, and only if the condition x in strings now is greater than 100 and z is less than 50, then we will get a result. And in this case, since we use random numbers, we get just one hit here. So this is the basic way of querying your data. Use list comprehensions in Python, and you can go over your tables and filter them out. So nothing new to learn here about querying. You can use everything that Python offers you to do your list comprehensions or other things to go through your data and read them and filter them. Okay, next slide, please. Yeah, so this is Just the same thing again here. And then once we are done, we can close our file. Next slide. Can close our file. And also you can modify, so even though you have arrays or tables, you can modify them. And for this one we use NumPy. So NumPy is also a very big package in Python. We import it, and so we don't type so much, we just call it capitalized N here. And then you open our file again, and now in a different mode, not in read or write mode, but in append mode that allows us to append to this file. Next slide. And then we can append data to the table we want. So now we just create an array. Inside this group level, we create an array. So far we worked only with tables, but we can also use arrays. And in this array, we just dump in our found. You see we use N, so we use NumPy to create a NumPy array, and we use our found results and convert them to an array and store them in our HFF5 file. Next slide, please. So now we have stored it inside. Then we can close it and we can look at it again, and you will see that in addition to the raw data table, we have the found array. Tells you it's array there, data set 4, and then gives you back the found data there. Next slide, please. Yeah, no, next. That's just the rest of this output. Going to 9. And there's a few tools, and one of them is ptdump that comes with PyTables, and it can also be used. And this is a little bit chatty here, tells you a lot of things. So if you type it in, it tells you a lot of the internal things about how this file is going to looks like, and gives you this information. And you can see down there they have all the table with default value of 0 and things like this. So you see some you can look inside your file, which is very important. Next slide. So that's the rest. Next slide, please. The rest of this output. And now we open our file again in append mode. And now we can append something to our table. So the table is not finished. We can append something. We just loop through, and we just let our index I run from 10 and 11. And then we just add a few more numbers, and again we say level append, and then we can extend our table. Next slide. And once we do this, we flush, you can see now we have 2 more lines in our, 2 more rows in our table. Next, please. You can also, it's very easy to modify values, so you can use this natural naming sim. You can just say tab calls name 0, and the index is 0, and then you can change it. You see now the name has changed. The name is the string we used, name, and now if you look inside the first row, you see the text has changed from this kind of index there as a string to changed. So this is a very nice way to change the values. Next slide. And you can also, if you like, to use conditions. So here now we again have conditions, and there's a thing called where, and with this where you can define a condition as a string. We say only if the index is greater than 4, where the index is greater than 4, you do this, otherwise you don't. And you see there, if you look at the output, only index starting 5 and higher has the text different in there, the rest still has value what we had before. So this one is a very easy way to change your data with a condition. Next slide. And also, you can also modify the arrays if you like to. You can access arrays just as you know from NumPy. So what we see here now is just normal NumPy syntax. We just do the slicing thing, and we can add a new different value there, just saying found 0, and found 0 is just changing the value of the second entry there. See, and if you echo back our array, you see we changed the value, which is very easy. Nothing special here. Everything you know from NumPy you can apply. And then you can have a few information about, you have the length of the table, how many rows you have. You can remove rows, so just say table remove rows and they are gone, and now the table is only 10 rows long. Next slide, please. So this is just kind of scratching the surface here. You see this thing, you can do much more. You can navigate up and down the object tree, so you can make very sophisticated object trees there, like very similar to directories, and go up and down. You have some kind of undo functionality, so you can undo the manipulation of the tree. You have a num data type, which allows you to do enumerations, which is a data type that doesn't exist in Python as it is for now, but it's in there. You can use multi-dimensional items, so one item, so far we saw only a number, can be an array, can be stored in a table. You can also nest tables, so you can have tables in tables and tables. And you can have custom attributes, and you can even, if you like, to pickle Python objects in there, so that's possible. Of course, if you use Python, you cannot read from other languages, but you can pickle things. Okay, so pretty much this is what I would like to introduce you today, and that's a few other things. So if you work with Python, Python has much more to offer. You have standard library that has batteries included, so they have a lot of other things in the standard library. You have a Python package index, and actually it's not 12,000, it's more than 13,000 packages right now. And you can do a lot of things. You can write graphical user interface programs with different libraries. You have plenty of web frameworks, and you can access databases and lots of other libraries for many different purposes.
So thank you very much, Mike, for that very in-depth dive. And now I'm going to probably take everybody to a very high level up there in the clouds and talk a little bit about what we're doing here to enable you to scale some of those applications. So one of the things is that we talk about often here in the ActiveState dynamic language world is the availability of all of the packages that Mike has described, plus thousands of more for both Python, Perl, and Tcl. So again, I'll just repeat all of the packages that Mike has talked about in this presentation are available in the Community Edition and the Business Editions of ActiveState's tools. So basically what we are saying is, as it says in the slide, we've got your universe covered regardless of where you're doing your work, whether it's on the cloud or not. If you go to the next slide. So the other thing that we're doing here at ActiveState is we have just launched a cloud platform so that you can take those applications that you're developing and if you have a web interface on them, like you're using Python and Django and running some of these scripts, or you're creating applications for external or internal use at your organization, you want to run them on a cloud or on your private cloud inside or on your own servers, whether they're running vSphere or on AWS or Amazon's web services, tongue twister there for a minute, or on Rackspace. We have the capability now of creating a very nice secure containers on the cloud for you to build, and if you're just doing research projects, to spin up what you need just as you're using it, and then spin them down so you don't have to spend the money on hardware to run some of these big data tests that you're looking at. We know that getting server time to run some of these very computationally intensive tests and research projects can sometimes be the roadblock. So what we're hoping that we can do for you is to make available to you space on the cloud that can scale to perform your tests and create your big data analysis. And to that end, we have launched Staccato, and we're in developer preview right now. So if you're interested in joining the developer preview or getting a VM to use to play with in-house, drop us a line. You can go to activestate.com/cloud and fill out the form, and it'll come directly to me. If you can go to the next slide. So really what we want to really make sure is that you have all the tools that you need to build your environment, so you can use the Community Edition. If you're building production or enterprise offerings, take advantage of our coupon code here, PYBE200 and take $200 off just for attending. And we will make sure that we answer any of your questions, and hopefully we can get you up and running with your big data projects faster and scale them quickly to the cloud. So with that, I think we want to open it up for some questions.
Yeah, if anybody has any questions, just use the question function in your panel, or the chat function works fine. And again, if we don't have time to get to them, we can we'll send you a response in an email. And so if you have any questions for either Mike or Diane, now is a good time to start asking them. We do have one. Just if we could go over again the distinction with the different modules that Mike was talking about as far as what's going on with those in Active Python for Community Edition or BE. So that's probably for Diane.
All right. So so we have multiple editions of Active Python and Active Perl and Active Tickle, depending on what your organization or what your project needs. The Community Edition is the freely available download edition. It includes pretty much all of the packages as is without support. And what's missing probably are the things, the database connectors that are specific to some of the larger databases. Those would be in the business edition. So if you're using Postgres, for example, or if you want to use some of the cryptography things, those have multiple libraries and issues around compiling and building those packages that make them a little touchier to build. So they are in the business edition as well. We have enterprise editions for those of you that are deploying this across your enterprise. And we have another edition that's called the OEM edition. So if you're building a product that you want to resell and make sure you have the distribution you need in your package included, those are the distinctions between the different editions.
We're getting a few questions about the slides, and I'll be emailing the presentation out to you after this webinar, and they'll also be available on SlideShare, so I will send that information out to all the attendees today. So I think that's it for today. So I want to thank Mike and Diane for your time today, and hopefully everybody got a lot of great information. Check our site back at activestate.com/webinars for more upcoming webinars. And again, I'll be emailing this presentation out to everybody. So thanks again for your time, and enjoy the rest of your day or evening wherever you may be.